Welcome everybody to Today in Space, and we're back for another episode of People of Science, where we get to speak with people who are working in the industry and talk about what got them into that career, what sparked that inspiration to get into STEM. There's a lot of folks here who might be going to school for STEM or went to school for STEM and are now out of the workforce looking for something new, or maybe you just like to know what people that work in science actually do. So that's what People of Science is all about. And this week we get to talk to Deniz from Global Foundries and talk about some really cool stuff around chips in space and really this cool intersection of art and science. So Deniz, welcome to the podcast and thanks for being one of our People of Science.
Oh, thank you so much for having me.
Absolutely. So tell us a little bit about yourself. Tell us your STEM origin story and what brought you to be working at Global Foundries.
Yeah, so these days I am the harsh environment battleground owner, and that's really all about getting chips into deep space and defense. And if you told me I was going to do that back when I was in high school, I would have laughed. I had no idea that career existed, let alone the path I'd be taking to get there.
Absolutely. Now, that's a wild title. Could you say that one more time for me? That's one of the coolest titles I think I've ever heard.
I know, right? I got to go get new business cards now that it's a formalized battleground in the company, but harsh environment battleground. And our company has structured, Global Foundries, right? We're all about chips, and we've got chips in your phones, chips everywhere. And we've structured our company so that we're oriented towards how our chips are used. And that means we have battlegrounds across different products. And a really big product niche is harsh environments, right? Chips that can withstand extreme temperatures and radiation. And that's where I play.
Absolutely. The battleground of going into space, right? That's a very unique place. And, as we are building towards on a national level and a global level with the Artemis Accords and the Artemis program, we're sending humans to the moon and beyond again. Those chips can't fail. So could you tell me a little bit more about like what's unique about the like aerospace space application for chips particularly? Like, are there some special processes or like how do you guys think about that in the battleground of space?
Yeah, no, that's great. So we're a high volume manufacturing company at Global Foundries. And, that means producing a lot of chips that are everywhere. So to be able to look at our portfolio and say which ones of these are intrinsically harsh environment, such that if someone comes in and a chip, right, I describe it as a hamburger, which
Okay.
layer upon layer upon layer, right? And each layer has a design associated with it. Those designs are either circles or they're lines, right? And those stack on top of each other to make a device and a circuit that performs something really unique. And so what we have to do is work with people who are really good at designing in redundancy and other mechanisms that work well and customized to specific kinds of processes. So that's my job, is to kind of make those connections. And that's what we call rad hard by design. And that's one way to do it.
And take us a little bit into like for some folks who don't know about silicone chips and wafers and things like that, could you explain a little bit about that process, even just at a basic level?
Yeah, chips, it's phenomenal, right? Like I think about the toys my girls are playing with now versus what I had as a kid. I'm like, I feel like, the monkey hitting the obelisk compared to their like dolls. They have a fairy that they can put their hand under and it senses them and then shoots back up in the air and they chase it around. And I'm like, that sensor alone, that's an amazing chip, right?
Yeah.
And it's something we just take for granted because it's like ramped up everywhere in all of our products that we use. But they're pretty complex, right? Because you take a wafer, right, an ingot, it's kind of grown out, you slice it up, and then you send it into the fab, right? And that we basically, do design upon design upon design on that wafer, right? There's different wafer sizes, 300 and 200, and those are our dies. And those individual ones at the end, after they go through 11,000 process steps or more, right, in a fab, then we cut them up into all the individual dies, and those go out into that sensor and that doll that's flying around in my daughter's toys and getting smacked, and goes through everything and somehow survives.
Yeah. No, that's crazy. And I think I've worked a few different jobs. One was actually metrology, so laser inspection, a lot of, people taking things apart, moving and having to assemble them again. So I've had to get dressed up in the bunny suit and go into those, clean rooms before. It's I think for most people, it's kind of shocking how much goes into protecting just the manufacturing process. Never mind, this thing's going to go on a rocket, shake and vibrate like crazy, and then go into space. I mean, that's wild to me.
Absolutely. Like the cleanliness of what you're talking about, having to put on a bunny suit, making sure you're bringing nothing into the fab that could contaminate. And then you go in this, when you walk into a clean room for the first time, it's an unbelievable achievement to see all these like vapors flying overhead and the automation and all the like mental power that goes into design them, and they work, right? That's, I
Yeah.
think the most amazing thing is they work reliably. And in my job, they have to work extremely reliably, right? And that's one of the terms that some people use is trusted, right? Trusted
Mm.
boundary by the Department of Defense, because you have to have that surety that they're not only produced well, reliably, and of quality, but also securely in these days. Because what
Mm.
if you send a chip into space, right? And then it's not a
Yeah.
securely produced chip and you don't know it till it's way out there. What do you do?
Mm. Absolutely. So what got you here? What got you into working into aerospace and like getting into STEM? You mentioned you didn't think that you'd have this job when you were in high school. What
Oh,
did you
no.
think in high school?
I really love to paint, play the piano, and I love math. So when I was a kid, I
Uh,
was kind of bouncing back and forth between what I saw as, art skill sets and doing music and loving my math problems. And it seemed like it had to be a choice between two different careers, right? Because of the
mm,
way we categorize learning skills for young people. So that was kind of my battle back and forth: is am I an artist or am I a scientist? And how does
yeah.
that work?
No, absolutely. Yeah, I had a similar art and science thing, although mine I've realized now mine was not the math, it was more like the scientific concepts, and for me it was jazz and playing trumpet. So that morphed into a aerospace degree and uh doing a podcast about space. So um where did I'm sorry, do I still play? I started again in the pandemic. I'm actually singing now, in a choir, which is a different. I had to completely learn how to hear again. But I injured my embouchure playing in senior year of high school, high, loud. I was first trumpet, and I was just, in retrospect, I had worked too hard, and I should have built my chops back. But I took a class in college, jazz history course, and I learned about some of the trumpet players that would go to Europe, and everyone was, competing with them and trying to say, "Hey, you should play higher, louder." And I realized what they were describing as a torn uh, muscle in the embouchure was exactly the same problem that I had. So I'm building that back up, but it's a process. So
It's got to be hard to have it and then lose it and then come back to it. Like that's
yeah,
something you're
that's
doing. Yeah.
absolutely. I mean, that's part of what I think brought me to do this podcast was that, loss of it and then just wanting to perform. So it's become this.
Amazing.
So from art to science, where did that click? Was that in college? Was that afterwards?
Oh, yeah. Honestly, I kept ping ponging back and forth. And
Mm,
I was very, very lucky. I had some, amazing people in my life that, kind of like I saw as amazing artists and scientists
mm,
and things like that. And I got a really unique opportunity when I was about 15,
mm.
where I ended up winning this scholarship through NASA to be able to
Wow.
go down to California. First time on a plane was flying down there.
That's cool.
And I worked at Hughes Space and Communication as an
Mm,
intern during the summer. And then on the weekends, there was a group of us that did this, and we got to go to like JPL, and we got to go to all these amazing places to
So
see.
cool.
It was like there. That was the first time, right? I walked into Hughes Space and Communication in a high bay, and I saw them building a satellite.
Oh my
And
God.
what really did it for me is when they took me in the back room to where they played ping pong to come up with ideas. So I'm like, so cool! Like, what a fun group of people.
Yeah.
So that was a big one for me, from like an influence standpoint. And then I also had the other side of it where a painting I did ended up winning a national contest and getting displayed in the Capitol building, which was
Wow.
surreal, right? And so,
Wow.
especially when we teach so much about like, what you're good at, it is like how you're supposed to label what you do, right? As
Mm,
opposed to seeing it as like a blend of skill sets that you can take wherever you want. That I
yeah.
don't know, maybe that was me, but it took me a little bit to see things a bit differently, that you go after like these as skills and piece them
Mm.
together.
Absolutely. And I think a lot of that, exactly what you're talking about, is it's what's brought me to this podcast, and it's what I think this segment is really about. I remember I was going to school for aerospace engineering in 2008, and there wasn't content online. It had to come from a book, and you had to be in a library that had this kind of stuff. So for me, it was kind of like, how do we get content out there? Because I didn't even know what job I really wanted or what I felt I could be good at, because it was so brand new to me. So this is kind of a way for folks like yourself and others who are trying to find that connection of what they're passionate about and what they could do for work. Um, I think you're spot on. How did so Hughes? That's crazy, huge satellite. Did you end up making connections there that brought you to the next stage in your career? But how did you get from there to Global Foundries?
Yeah, no, so that the time of use, I was only 15 years old. So I was still in high school, and it was just like it was an unreal experience, absolutely amazing
That's
program that the
incredible.
United States offers. Like, do more of that. We like as young people, we need to see what it's really like because it's so
Yeah.
different than the classroom. And unbelievably grateful for that opportunity. And then when I got to high school, I was like, well, I'm going to be an art major. Like a
Yeah.
little and I started, I did that, but I couldn't stop the math, which because I loved it. So I just
Yeah.
kept taking advanced math for a while and then going back and forth. And then
Mhm.
eventually I was talking to a physics professor and they were telling me about the research, and I was just blown away. I was like, oh, I'd love to help out with that.
Yeah.
So how I ended up, they said, oh, come do a major in the material science department.
Nice.
Um, and I ended up doing a portrait for them. And then that turned into dog portraits. So I kept doing dog portraits. And then somehow it turned into research. And then I was going to, you know what I mean? It's one thing
That's
after another. And I never would have guessed it, but I just kind of followed what my passion was and
yeah.
somehow ended up with some, amazing people guiding me along the way.
Mhm. Yeah, and that really seems to be the common thread with a lot of folks is, it's the people that you meet. The degree and the things that you learn in school are great. Um, but like at the end of the day, if you can see a job that would actually like, or people that you would like, then you know to look for that.
Yeah.
And yeah, that's huge. That's huge. So wow, so yeah, the art brought you into the science. That's amazing. Were you conscious of the art and math uh like combination? Are the two the same for you, or do you see them as two different things?
Well, I'm going to go back to music because I think you can probably relate on this one, but the way music is written can be so mathematical, and there's
Mm,
something really amazing about the patterns in it. So for me, part of it's that there's an art to the math of it, and
yeah.
I'll never forget when I finally got to a math class where it connected back to something real. I feel like you have to get really far in math for it to suddenly
Yeah,
make sense from a science field perspective.
totally. Yeah.
So yeah, it kind of went back and forth for me.
I love that. No, that's great. And I feel like that's how it is. There's so much that you can learn from it. Like it's you're just gonna evolve as you learn about it.
Yeah.
Yeah.
From there, I ended up doing research, which is
Mm,
what really changed me. And,
mm,
it was recommended to me to try out some research, and I was doing it on what we call electro optic polymers. There was a professor that who was building out these unique polymers. So I started testing them while I was in college. And then there was another university down, University of Arizona, that was actually building the modulators. So I started going there in the summers to build them and then coming back. And I did it back and forth for a few years, right, while I was finishing up school. And then they're like, well, if you like this, you should get a PhD. And I'm like, oh, okay, tell me more.
Yeah.
And that's how I ended up getting my, PhD in polymer physics. Was I just wanted to do more research, and then landed at Global Foundries. So
that's incredible. How was the PhD process for you? What did you enjoy? What was challenging?
It's all about learning how you learn, right? Because it's, so much in school for me is not like what it is when you're in a workspace. You're learning skill sets, and you're learning how you work, and you're learning what makes you tick, right? Like, are you someone who wants to dig into the details and then, come out a few days later and be like, hey guys, I figured out a pattern and I want you guys to run with it? Or are you someone that wants to stay at a high level, but know how to poke to dig in at the right times, with the people you work with? And, like, are you someone with a big vision, or are you someone with a lot of like detail? You know what I mean? I could go on and on, but it's your skills, right? Like what makes you tick. And that's, I think, what a PhD does, is it gives you this huge open project, which for me was about cataract formation. And it's, about like how do these proteins in your eye aggregate over time to form cataracts, and what can you do to change that? And once you dig into solving that problem, you learn a lot about how you learn.
That's awesome. Thank you for sharing that. So Global Foundries, you get there. What was it when you first started? Was this the role that you were looking for? Did it take some time? I think folks would like to know, like, how do you progress in a STEM career once you get to a place that you like?
I feel like it's always tough to get your first job, right?
Mm,
Because
yes.
for me, I was in school a long time. I wasn't sure how it really translated to what was out there. So the thing that blows me away about the generation of kids that I'm seeing coming out of college and reading their resumes is they're doing so many internships
Yeah.
every year. And I'm like, that's the right thing to do, because then you pick up what you're doing and how to translate it. Because figuring out, hey, what skill sets did I learn here can translate to the job that they're advertising, that I don't know a lot about based upon a page of, bullet points and
Yeah.
acronyms that everybody seems to know but me. You know what I mean? Like, for me, getting the first job is tough, and I'd really recommend stepping back and going through it with someone to see how you translate your skill sets to a specific job. You really got to go after one job and really customize your resume. So for me, that's, I jumped into my first job and it was in lithography. And that's, for polymers in semiconductors, they're the temporary layer, meaning, that hamburger I'm talking about that you build up to make a complex chip, to be able to etch into it to make a permanent pattern, you have to put a temporary polymer first. And then you use a mask, right, which has holes in it, and wherever the light comes through, it'll change and cross-link, right, and then you wash away the rest. So you end up with a temporary pattern, much like lithography, press printing.
Right.
It's just with a mask and with light. And so that was what I started in, but I actually did extreme ultraviolet lithography, which is 13.5 nanometer wavelength light.
Whoa.
Yeah.
That's so, and that was doing the etching, was the UV?
So the way it works is like the wavelength of the light that goes through the mask dictates the size of lines you can pattern. So 13.5 nanometers, depending upon what kind of processing you do or whatever, but it can get to, 7 to 5 nanometers or even less if you're really creative. But basically the light goes through and it cures part of it, and then you wash away the rest, and then whatever's left you etch down, and the parts that are protected don't get etched, but the parts that are, right? So it kind of makes these temporary patterns to permanent patterns in silicon.
And it's giving you the pathways for all the things that these circuits need.
Exactly. It's one layer at a time. So you've made your lines on one level, and then you now go and you deposit a new material, and then you do the same thing again, but now in a new material. And that's how you kind of build it up. And you make all these connections through the metal.
Very cool. Very cool.
It's the amount of people it takes to make a semiconductor, like, and the amount of technical depth for each aspect. There's layer owners, people who are phenomenal
Wow.
experts about every aspect of one layer because it's so complex.
Oh, I love this. Let's dive into that because I think that's a cool way for people to think about jobs that could exist around a technology. So you have layer owners. Are there people for each specific process, or is that part of the layer ownership?
You're hitting the nail on the head. There's so many different kinds of jobs. There's someone who owns the layer of it. There's someone who owns the tool. There's someone who writes the instruction manual for building the chip. I worked with someone who, the job before writing the instruction manual for the chip, she worked at the CIA, which was the
Dang.
Culinary Institute of America, not the other one, but I know I'm in aerospace and defense. I had to make the joke, but
It was good.
no.
It was good.
But no, she used to do all this amazing cooking, and she would always be giving me tips. And she also had this great mind for technical writing. So what kind of degree do you need to go into semiconductors? Anything you want, right? It's really about figuring out what skills do I know that translate. We obviously hire people with, EE, MECE, like we also have so many range of jobs, like right out of college, right out of high school. We have technician training programs for people who are new to it and want to ramp in. It's really, are you passionate about it? Because, there's programs in place to get you to be the expert you want to be.
Yeah, that's awesome. This is exactly what this this segment is about. So thank you for sharing all that. Folks, let's take a quick break from the episode to talk about the new merch. That's right. Today in Space merch, the Starship pen is done. And here you're seeing all three versions of what we have. RUD and black, the Galactic Q blue, and the Terraform green. These are the hexatubes that hold your Starship pen in there. And we've been doing some work to make sure that they ship without moving around, so they're not damaged in the process, and so that you can bring this around. And another addition here is the Starship Tower horizontal display stand, which hooks right around the existing hexatube and allows you to space nerd out in all your glory and have the pen with you at your desk, wherever you want this to be. And once you're using it, you can put it on display. That's what was missing when we had the first prototype out there. But every order will get this whole thing. The price is still $65, even with all these improvements. And because you're listening to the podcast, there is a discount code. Discount code is RUD23 for 25% off the $65. If you're in the US, free shipping. Go to ag3dprinting.etsy.com, look for the Starship pen, pick your hexatube color, and get one of these Starship pens. It's a great way to support the podcast, and it's really the first premium merch we've done here. So every Starship is unique. It'll come with a part card that will have your Starship number, your unique Starship number. So order today, get free stickers, and all of this amazing premium stuff for your space nerd needs. Thank you for all your support. It's ag3dprinting.etsy.com, RUD23 for 25% off, and free shipping in the US. All your support means everything, and this helps us do a whole bunch of other stuff. But without further ado, let's get back to the show. So now with being the head of the Battleground for aerospace and defense, tell us a little bit more about the application of these chips. Like how wide ranging and I guess anything that you think is like really interesting that people might not know about that.
So I was talking about the instruction manual for the chip. We of course have an acronym for it. It's the PDK, the Process Design Kit, but it's such an open-ended thing, right? It says, hey, here are rules for how you make your lines line up and how your contacts connect your lines. And that's what our customers are given, which means anyone can take these instruction manuals and then build any kind of chip they want.
Mhm.
And so my job is to help people be able to build chips that survive in deep space, right? They're the design experts. They're the ones that know how to make redundancy or dissipation mechanisms or whatever they're doing based
Right.
upon what kind of environment they're going to be in. But it's my job to help them find technologies that are intrinsic as well as pathfind to get those intrinsic platforms available in secure facilities, right? Because they're
Mhm.
doing really unique things. And some of them are just these amazing academic purposes that are going into space. But due to the advances in cybersecurity, as well as hardware changes, it's critical that those are secure and built in a trusted facility. So that's really what my job is to help bring those onshore in the United States and
Mhm.
get them in secure facilities and then get people ramped up with the right connections and experts.
Well, and it's interesting to think about how chips. I think there's a lot of folks will think, the direct person, like the person who's launching the rocket or the person who's sending the spacecraft. And what the chip just allows us to do is completely design a mission based on, what we can push through this chip and what it's capable of calculating. Um, it's really a crazy enablement that we're able to do with this. And it makes me think of automation and everything that we're seeing with AI and a chip shortage at the same time, just globally. How does automation play a role in creating these chips right now for space, or in
Automation,
general?
yeah, automation is critical because it allows us to put people on the things that we need to innovate,
Mm,
right? So automation is gonna, we use automation to ensure security in some cases,
mm,
as well as get all the data to these minds that can go through it and figure out the patterns and what we need to do next, right?
mm.
You want to put people on certain kinds of jobs and you want other things to enable those people to do their job better. And that's what automation's for. It's really helping them to do their job better.
Yeah, and from a creative perspective, I think AI and things that are coming down in the future make a lot more sense because I'm trying to use it and not just read a headline and think I know what it does. And for me, how I'm trying to use it as a creator and even as a scientist, I'm trying to help it do the work that it's just going to take me too long to do. And I can kind of pull back from a project and say, okay, instead of being in the mud all the time, I can kind of be like, okay, well, AI is helping with this. Let's focus on what the really big picture is here. And it feels like the people that are figuring that out now or know it now are the ones that are really taking advantage of it.
Absolutely. I think there's a critical place in, I mean, we're at that part of the curve where technology's taken off, right?
Mm,
And in terms of what we can do and how much data we have, there's a lot. But being able to facilitate that data in a way that we can take intelligent action
yeah.
is a very tricky thing, right? And that's going to
Mm,
take a few rounds, but we're getting there already. I mean, just if I, again, I reflect on, when I look at the changes in I have a 3 and a 7-year-old, right? The
yeah.
changes in their life, of what's commonplace to them versus what was for me and my, AOL dial tone that was novel, right?
Yeah.
You know what I mean? Like it's
Yeah.
it's it's a huge change, right?
Mhm.
And
And
it's
that
a
was a huge
huge,
change.
right.
Yeah. Yeah, absolutely. I've been erring on the side of, it's way better to understand it because as soon as it becomes magic, that's when I think it's trouble. So,
Absolutely.
yeah.
Absolutely. I agree with you. And that's kind of, I don't know, the thing that amazes me, but it's also at times it's like, oh my goodness, there's so much more to learn. There's so
Yeah.
much more, right?
Yeah.
Uh,
Yeah, it is well. But that's the STEM field for you. It's a never-ending gauntlet of learning. It really is.
yeah.
So what are some unique challenges in, you know, designing these and also like integrating for high volume manufacturing?
Sure. Yeah. So for harsh environment, like getting chips into space in particular, there's there's two primary ways to do it, right? There's, I talked a little bit about design, right? Like this
Mm,
idea of an instruction manual, and that's called rad hard by design. But there's a whole nother methodology called rad hard by process. Rad hard by process is where you look at that instruction manual you give and we say, well, if we make these changes here, it's actually going to harden your chip. And what does that really mean? Well, let's step back and look at what's going on in space right now. There's, the here and there unique academic launches, right, that go into deep space. And those ones, they go through a lot of rigorous testing and qualification to
mm,
get them into deep space. But we have something really amazing happening right now, the commercialization of space. There's hundreds of stuff going up. There's doves, there's,
yeah.
like all these like, satellites. Like someone built a satellite out of Legos, got it into space, and it worked. Like how did that happen, right? And essentially what that means is they're sending up commercial chips which aren't rad hard by design, and
Mm,
that's great because it's new and they're getting that data, but they're decaying very quickly.
mm,
And if you look at what's going on in legislation right now, people are finally starting to say, wait a minute, we got to clean up space. We got to take care of it. We can't just launch a
mm,
bunch of stuff and let it die. That's not a long-term business model that's viable for us as a whole if we
yeah.
want to keep progressing in this field. So that's where rad hard by process comes in, because it says, hey guys, you don't want to spend 8 years or 5 years qualifying your designs and making them custom.
Yeah.
Use rad hard by process. We just change out the process a bit. Your existing designs suddenly get a bump and they last longer in space.
Mm,
Like we're solving a little bit of that sustainability problem by giving them better chips without asking them to trade off on their time to launch. So
mm,
that's where I see things going. And that's what I'm really, excited about collaborating on, is how we go
yeah.
after rad hard by process with other companies.
It's incredible because we both were young enough to see an aerospace industry that was just choked out and ready to pass out. I mean, it was scary there for a little bit about whether or not the U.S. was going to even keep its space station up in orbit. And never mind, being locked in with the Soyuz system to send humans into space. Um, with all of these new satellites and commercial launches, there's so much more opportunity for things, so that's very cool. For some of the new stuff that's going out there, um that little extra bump that you're talking about, I've been really thinking more about the ownership that people that are launching things into space have for the entirety of that ship's craft's life, from launch to deorbit.
Right.
And it sounds like even just at this level of the process where you can give yourself the opportunity to do that. Yeah.
Exactly.
Yeah.
It really gives them another option. Because I mean, their
Yeah.
primary goals are, hey, we want to launch fast and we're okay with making mistakes because we want the learning that comes from it. We want
Mm,
to get things up there and we want to collect a lot of data and then make new choices, right? And it's
right.
enabled all these new companies across the globe, which is fantastic, right, for
Hmm.
advances in science. But now we're at a stage where enough has been up there that we're recognizing a new pattern, and it's,
Mm,
guys, it's getting messy, and we've got to take
yeah.
care of it, right?
Hmm.
We've already seen what happened on the planet when we ran fast without
Yep.
acknowledging,
Hmm.
repercussions. So let's be a little smarter as we advance into space. We're now moving beyond ourselves. So I think this is a great time to say, hey, what can we do a little bit different and work together to meet your goals of
Mm.
getting up there quickly and advancing, but still thinking about it in an intelligent way that's going to allow your products to last longer.
Yeah, and it's funny. I was talking to some friends the other day who, we were talking about Mars and the moon, and people were kind of like, well, why wouldn't we just fix stuff that's here? And the more that you look into these space applications, much of what we're doing or trying to do with all of it is stuff that can be used here on Earth, and using every single bit of resource and reusing every bit of that resource as many times as possible, um, in order, in some cases, recycling it. Like those are all things that we actually need here. So it's almost like space is the battleground for us to learn things to then use here to fix it. And I really do think that metaphorically and symbolically, like the earth and being on this rock by itself and not having the option to go out into space literally conceals us in a bubble. And it getting outside of that is just like breaking out of the box, thinking about things. It's just we got to get more people talking about it and thinking about it. That's my thought about it, anyways.
Oh, no, I completely agree with you. And, the thing I'm visualizing while you're talking is, what about people living on the moon? Like, what kind of
Mhm.
infrastructure would we need? And then if you step back, what that means from a zero footprint perspective for someone to be able to survive up there, right? That's learning that we could translate heartily to what we do on the Earth,
Yeah.
and the infrastructure we'd have to develop. I mean, it's a phenomenal concept, and it's what we're marching towards right now. And in
Mhm.
terms of energy, looking at reactors, it would really allow us to reevaluate what we're doing here on Earth. We
Mm.
have history, right? In terms of how we've gotten to where we are and the fears we have in different countries. It's because of the history of how we got here. But if we were
Mhm.
able to step back and come up with a neutral solution for survivability on Mars, we might suddenly realize that there's been so many advancements in reactors or other things that would cause us to completely change what the best case scenario is, because we throw everything out, right? That
Yeah.
history doesn't come when you have to build something new in
Yeah.
a that's completely science defined on your restrictions, right?
Mhm.
You're going to pick the best case technology. And it's only then that people are going to be able to let go of the history of how we got there on Earth and actually
Yeah.
implement change. So I agree with you completely.
Yeah, I really do think that s- there's an opportunity for space to be a beacon of hope for just like we had back in the day. I mean, the I call it the space conundrum, where the space progress conundrum, where the last time we had this kind of progress in space, we were also facing civil injustices and wars and all of that happening all at the same time. I don't know why the two have to happen at the same time. I would prefer it didn't, but it has repeated itself, so it's just a strange thing. And so I that's where my hope comes from, even though that means we're in some strange times.
Yeah. No, I absolutely agree with you. I mean, it's absolutely amazing what we have in the United States, and in terms of our ability to focus on um, arguing back and forth that we don't agree, but we still make decisions and move forward together. Like,
Yeah.
that's phenomenal. And yes, sometimes it leads to delayed decision making, but it leads to the best decision for our country, right? But
Hmm.
that's not the way every country operates, right?
No.
There's in some countries, it's I'm going to make the decision, we're going to do it no matter what. And
Hmm.
it's also like, I'm going to tier information so that not everyone can see everything, and then we're making a decision. And as a result, yeah, there's always going to be that push and pull when someone starts to advance and another country wants to push back until we find a more uniform way of engaging. But yeah,
Yeah,
I agree with you.
absolutely. So let's talk about some fun space stuff here. So um have you been following along with James Webb Space Telescope at all?
Yeah, we've actually, so this is really cool, but like, we have chips on there. Like,
That's
how
amazing.
amazing is that? I
That's
mean,
incredible.
I know, right? Like, so we've got a global footprint, right? That's why we're called Global Foundries. We're the first um, fab to really think that way, which was phenomenal for our fab because it helped us to be resilient through the supply chain. But we have a fab up in Vermont.
Mm.
They actually made chips that went on James Webb Telescope.
That's
Yeah,
so cool. That's so
right.
cool. Um, I mean, what it's done to show us the universe in an even more advanced way than Hubble is kind of mind blowing. I was born, I think, a month or two before it got into orbit, but It's just crazy to think about that and how much, everyone's screensaver has a Hubble photo. Now it's going to be James Webb photos. Has has what you've seen come back from James Webb Space Telescope, and also knowing that your chip survived the origami unfolding in space, uh, what's your take on what it's done, and how does it make you feel?
I love to paint, so I love,
Mm,
for me, it's inspiring in that sense. I do a lot of unusual paintings here and there on that side, on the personal side, right? And on the personal side also, I just, uh, it's amazing to think that something that all these minds came up with and said, "Hey, let's go get it out there," and it worked, and they did it. And it's not just, one or two people, right? That's
yeah.
like the thousands of people have touched different aspects of that to be able to make it a success, right? There's
Hmm.
so many skill sets in terms of,
Yeah.
or you need someone to organize things and program
Hmm.
manage things. You need someone to understand the mechanics of the materials. You need someone to build a chip and
Hmm.
understand how that's going to drive the brain of it, right? Like all these different aspects require such different skill sets, and people all came together and they did it. And now we've
Yeah.
got photographs of space. Like, it's pretty cool.
It's incredible. It's
Yeah.
incredible. Have you been following along on any of the more commercial, or I should say civilian, space launches like Inspiration 4 or Dear Moon, or what Blue Origin's trying to do? Um, have you been following along on some of those launches?
I've been reading this book. Gosh, now I can't blank. When the Heavens Went on Sale.
Oh yes, I've been going through that as well.
It's like it's a fun. Yeah, it's such an
Is that
interesting like.
Eric Berger? I'm trying to remember if that's his book or not.
I don't think that was him. I think it's Jamie.
I'll look it
Is
up real quick,
that
but
right? Yeah,
continue.
yeah.
Yeah.
No, no. For me, like the story of how these companies have come out, swinging, and to be able to actually launch things into space successfully and then create business models and succeed,
Mm,
it's huge. It's
wow.
it's such an advancement for science to have so many people going after it with
Mm.
success. What are your thoughts on it?
So, and it's Ashlee Vance,
Actually,
who did it. He did a great, biography on Elon Musk, back in the day. That actually was very good for prepping me to get into the tech, industry, surprisingly enough. So he does good stuff. But yeah, that book is very interesting because the SpaceX story is so told so many times, but there were so many other stories happening, and this whole industry was being lurched forward even though it didn't necessarily want to be. And it's or in the way that it was, I should say. um, and to see all these individuals that came together, made relationships, and the stories that are in When the Heavens Went on Sale, we're really seeing the next generation of it happen right now, where a lot of the folks that join those companies have trickled off, and it's almost like a trickle down effect of the whole industry. We've had these cowboys, of for lack of a better word for it, aerospace companies, um, advance everything, and now everyone's got ideas that they see are possible. So that book, I think, sets the ground for what's happening today really, really well.
yeah, and it's made for an interesting split in the space industry, right?
Mm,
Because historically it was all, a few US government and defense industrial based partners. We call them DIBs because we love our acronyms, but it's,
yeah.
these companies who get out there and actually make the satellite, right?
Mm,
And it was historically just those players, right? And then with this new push of all these creative minds coming out and making companies and finding ways to launch on their own without having to
yeah.
ride on other, government launches. Suddenly you get all these new businesses. But from my perspective, it's created two kinds of business, right? And
Mm,
that's the people who still go through the rigorous long-term qualification to get it into deep space and make a chip last a long time.
mm,
Um, and then need that like security aspect. And then there's those people who are just giving it a shot and taking whatever they can
yeah.
get Exactly. Which,
Yeah.
both models lead to different kinds of disruptive innovation, right? Like
Yeah.
in terms of, one finds rigorous data to really refine what's going on. The other one finds unique disruptions that suddenly can make a big difference. And those two
Mm,
together, running fast, is what's going to change, in my
yeah.
mind, the space industry. Because we're
Absolutely.
now being able to piece together the best learning from both of those. And,
Yeah.
I see kind of a conflict, sometimes within companies when I talk to different folks, because some of them still adhere to one versus the other. But I
Yes.
see them both as being critical. I don't think there should be a conflict. I think we need both of those kinds of movement to happen. And
Mhm.
it happens to translate right to Leo versus like deep space
Yeah.
due to the rigors of survivability. But I think it's what's critical for advancements.
I completely agree. And, and this podcast has also been like a uh medium for me to kind of challenge, like put it out there. And if I'm wrong, I'm gonna say, yeah, I was wrong. And I was stuck in that new space, old space um argument for a while until um I started going to see a launch, and when I saw my first launch and saw the people that were there, um it like you said, it's about the industry and everybody progressing, and um it's really a really cool thing. And I think the challenges of the division will be there, but um I think there's way more people that want to just make it happen. If we didn't have 10 years of real slowdown in the industry, I think that division could have been a lot stronger, but people just want to go to space. Like, let's go. It's the time.
It's served to bring in new generations
Mm,
this passion. And like in that amazing book we were talking about, there's these folks who came in green and somehow after a few launches managed to get it to work in a different
mm,
way. So I mean, you've
yeah.
just brought in a whole new set of information to a field that needs to innovate. So that's a
Mhm.
fantastic thing when you start cross-pollinating all these minds, which
Yeah,
they're amazing minds, so why not?
absolutely. And, NASA's done, a good amount of research on, like, okay, if we were going to go to Mars, what are all the technologies we need? Even the moon, what are all the technologies we need? And when you look at the problem, even from that detailed a perspective, you need a lot of different minds. And like, one of the great things I've had, I'm probably over a decade now in the workforce, and after seeing new people join and being a new person a few times, being a fresh set of eyes is one of the most valuable things that you can be on a team, especially when you don't know anything. And I think it's being okay with the fresh eyes, and welcoming it, um, and welcoming honest feedback of, hey, like, why do you guys do this way? Like, that just doesn't make sense. And then having to give a reason for it, that keeps everything fresh. It keeps everything um honest, because we're humans and we can get caught up in that stuff. So I feel the industry, and specifically the even the military side, the defense side of things, with Space Force and people like Embedded Ventures that are trying to, get the private advancement with the military side of things. I think it's a beautiful thing that we're starting to see happen with fresh eyes.
Absolutely. I mean, what an amazing thing there was Space Force and their
Yeah,
flexibility to make changes in what they're doing and their collaboration with the Air Force. Like, I think that speaks volumes about what we're doing as a country. It's exciting to have guardians going out there and looking at
yeah,
this new arena of what we can do from an innovation standpoint as well as defense.
absolutely. So as we're closing out here, are there anything we didn't touch about Global Foundries that you wanted to mention, and even, folks that are interested in this and where they might be able to apply, or how they should go about that, or anything like that?
Absolutely. So I've been with Global Foundries for going on 13 years now.
Awesome,
And
congrats.
I've done all sorts of jobs at Global Foundries. And I ended up landing at this job and then creating the harsh environment Battleground with, of course, the collaboration and expertise from my colleagues, working together. But my point is just, you never know what you're going to go after. And we hire so many different kinds of people. It's really about what skill sets do I have and how does it translate? You may see some unusual job online and think to dismiss it, but don't just translate what you have and into what you're passionate that you're reading about. And that's what people want is they want to work with someone who's passionate. And
Yeah.
I think it's a huge difference. And fresh eyes are critical. We have one of the best intern programs in the country. I just had an intern work with me, and he's phenomenal, just bringing in new eyes and really innovating. And he did a lot of work, because we really want to go after harsh environment battleground with security and care, right? Due to a lot of export controls and other things. And he did all this phenomenal work training the internal teams and learning about it himself, and then connecting and translating between legal and technical. And that is a hard job. But
That's
coming in with
very
fresh
hard.
eyes, he was able to do it, and he did it well. And my point being, you can come in with any degree. So, just take a look at the jobs and go for it.
Awesome. Is that on the Global Foundries website? Is that the best place for them to look?
Absolutely.
Cool. Um, any last words for anyone that's looking to get into STEM, or even just as from your unique perspective that you'd like to close out with?
I want to see more artists hired. That's my thought on life. I feel like that's one of the reasons I've been able to communicate some complex ideas is I have my simple visual mind where I like to translate things and imagine. So, for me, I'd really like to see the industry as a whole opening up their lens.
Mm,
Let's look at really seeing how we bring in different perspectives into the room. And that's not just different job titles or different what kind of diversity. It's really this person has a really unique way of seeing the world. Let's bring them into the room and see if we can argue and then come to a new conclusion.
I love it. Thank you, Denise, for coming on People of Space, People of Science, and talking about all things space, and sharing your experience at Global Foundries and the harsh environments battleground. Thank you very much for joining us.
Thank you so much for having me. I appreciate it.
Absolutely. Folks, spread love and spread science. Be well, be good to yourself, and we'll see you on the next episode of Today in Space. See ya.